Welcome. In this video I'm going to show you how you can obtain the Wilcoxon signed rank distribution using Microsoft Excel and the recursive method. Easier would be, I think, to use my StickPad E add-in, which simply has a function to do this, but if you don't want to use that, I'll show you how you can do it without it. This video will focus on how to actually do the distribution or obtain it, not so much about the concept. For that I have a separate video. Alright, so let's dive in. The recursive method. I have a little setup here, so that makes it easier. We need an example sample size, so I'm using 5. This could have been any value, but 5 seemed to be a nice number there. And then the first thing, or actually the second thing, is then to determine the maximum possible sum of ranks. Now this is easily done with this little formula. So what I do is I take the sample size, multiply it by the sample size plus 1, and divide it by 2. Then we set up our table. We create a table with columns going from 0 to that maximum and rows going from 1 to the sample size. So 0 to 15 in my case, that's over here, and 1 to 5, that's over here. Alright, then the next thing is to finally use that recursive function. That's this function over here. Now you might notice here it's using a binomial coefficient, but that's actually the same as that n times n plus 1 over 2. So I'm actually using that instead of this one. And the recursiveness comes from this last bit, which has to take the x minus y, y minus 1, and then add x, and then y minus 1. Now, in the beginning, this y will be the same as n, and x will be our t value. So if you look closely at this, it actually means that what we should do is, if we focus on the second part, we take the same x value. So for example, if t equals 6, we simply stay at t equals 6. But then we subtract 1 from y, so actually one sample size less. So this would be to actually say then, okay, well, we're over here, and we're going to at least add this one over there, if we're using this function. Similar here, this also looks at the previous one, but then it says to use x minus y, so we're also actually shifting then in the column, so a lesser t value, which depends on the y that we have over here. Now this part we can obtain, or actually do, with Excel by using a so-called offset function from Excel. The conditions over here we can also implement. So this long function that's over here, what it does is it first checks if the t value, the x, is actually less than 0. There's a $sign there. That means it will block the row number, so it will always look at this row. But of course, if I paste it to the right, it will change to the different column, in this case then to k, if I paste one to the right. It's checking if that's less than 0, so that's this condition. And if that's true, then it will put in a 0. Else, it's going to check if it's bigger than, and then it's using the combin function, which is actually this one. Instead, I'm not really using this one, sorry. I'm using the combin function. And it's simply then saying, okay, well, it needs to put in the y that it's actually using, so that's over here. And then add 1 over 2. Alright, so that's what this one is checking. If that's true, then it should also be 0. Alright. Then we have the third one, which is if both, so AND function, if the y, so the x, sorry, no, if the y equals 1, so if this one equals 1, which is true, by the way, in this case, and also the t value is a 0, so the x equals 0 or the x equals 1, so that's why there's an or, and then there's the 0 and 1, then it should give us a 1. Now I have one additional criteria, which is not really in here, but if the t value minus the n is actually less than 0, that means it's going to be negative, then it simply can take the previous one, because then this part will be negative, which will result in a 0, and then this part will simply be the previous one. So then and it just takes the value of the previous one. In all other cases, it will actually do all of this, which means to offset. So it takes the previous one, that's what this part is, and then it offsets J6, so the one row above, and this is the number of rows it's going to shift. It's not going to shift any rows, and it's going to do minus the number of columns, and that's the n. So that's what all of this actually then eventually does. Alright, so that's one huge formula. Once it's in there, you can copy paste it all the way to the last one, which is the one for our sample size of n of 5. That's the biggest step. After that, it's fairly straightforward. We probably want the probabilities, the proportions. So what we simply do is we take the count of the last one and divide it by the sum of all of them. If you don't want to use the sum of all of them, you could actually use simply the n times, what would be the sum? 2 to the power of n. That would be the same. So the sum of these, as you might notice, is actually 32. And if we would do equals 2 to the power of 5, we actually 5, we actually also get 32. So that's another way of obtaining the sum. I've used here the sum, so and I divide it simply by that sum. Dollar signs again, because the sum should always be exactly this range. Copy paste this formula to the side, and then we have our probabilities. We can also do the cumulative probabilities then easily. The first one is simply the same as the proportion, and then after that it's the previous cumulative proportion plus the current proportion. And then you can copy paste this one all the way to the right. So for example, if we have a sample size of 5 and we have a t-value of 6, then there are 3 different ways that we could have obtained this sum of ranks of 6. It has therefore a probability of about 9.4%, and to obtain a sum of ranks of 6 or less has a probability of about 40.6%. Alright, that was it. I hope this was helpful, and thank you for watching.